think that's so far away.
All right, guys. So looking at our test for tomorrow is for the whole unit. I know we've been doing proofs lately, but I need to review for everything. So starting on the first four questions, we have the triangles on the inside. That little box represents 90. So I know I have all three angles. Remember, if you add all three angles of the inside equals to 180. So for question number one, let me just go x plus 42 plus 60 plus 90 is equal to 180. Right, I'm adding the three angles, and then it's equal to 180 because it's inside the triangle. Let me separate my sides to the equal sign. The left side, we can simplify 42 plus 60 plus 90. How much is that? 192. All right, so we have x plus 192 is equal to 180. My plus 182, let me bring it to the right side as a minus 182, negative 12. Right. X is equal to negative 12. I know angles are positive, but the letter x can be negative. So negative is okay. So that's how we do the first four. Now, looking at question number 5, we have an angle on the outside. Now remember, for this, we add the two angles on the inside and equals the angle on the outside. So what I mean with that, 70 plus 5x is equal to 10x plus 15. Let me separate them through the equal sign. Each side is as simple as we can go. So let me choose letters on one side, numbers on the other. So my 10x, let me move it from the right to the left side as a minus 10x. My 70, let me move it from the left side to the right as a minus 70. Remember, every time I move something from one side to the other, switch the sign. How much is 5x minus 10x? Negative 5x. How much is 15 minus 70? Minus 55, yes? So negative 5x equals negative 55. What's x? 11. 11. So once again, the first four, add the three angles equals to 180. 5 through 8, add the two angles on the inside, and equals the angle on the outside. Any questions for the first 8?
No. Can we do another one?
Number 3? Alright, let's take a look at number 3. That's angles on the inside. So I'm going to add all three. I'm going to go 140 plus 20 plus 2x is equal to 180. Let me separate into the equal sign. The left side can be simplified. How much is 140 plus 20? 160. So we have 160 plus 2x is equal to 180. My positive 160 on the left, let me move it as a negative 160 on the right. How much is 180 minus 160? 20. So we have the 2x equals 20. That means x equals 10. I'm taking the 20 from 180 minus 160. That's where we got the 20 from. Yes.
Uh, number 8.
Number 8. All right. Looking at question number 8, I'm going to add the two angles on the inside. 5x minus 9 plus 96. And this is equal to 14x plus 6. Add the 2 on the inside and equals the 1 on the outside. The left side can be simplified. How much is negative 9 plus 96? 87. So we have 5x plus 87 is equal to 14x plus 6. All right, let me move my 14x from the right to the left as a negative 14x. Let me move my positive 87 to the right as a negative 87. How much is 5x minus 14x? Negative 9x. How much is 6 minus 87? Negative 81. Let me divide both sides by negative 9. X equals what? 9. I think by now, those of you that have been here with me since the beginning, you guys know my style of adding and subtracting or solving equations. Next year, for those of you that are moving to Algebra 2, your teacher will go back to the way you guys saw it in Algebra 1. If you guys want to learn my way still, if you guys need help next year, you guys know where I'm at. And so your teacher will solve equations the way you guys used to solve them in Algebra 1. I think this is easier. All right. Now let me move into question number 9. Question number 9 is asking me, stated that 3 numbers can be the measures of the size of a triangle. I look for the 2 small numbers. In my case, they're listed from small to large. They're not always listed from small to large. They're just listed in any order. So I look for the 2 small numbers and I add those two. 5 plus 7. Add the 2 small numbers, and then this is asking me if it's bigger than the third side. 5 plus 7 is more than 12. No. No. So then, no. They cannot be triangles. I know they're equal to, 5 plus 7 is equal to 12, but it's not equal to, it has to be bigger than. Any questions up until 12? Yes. Add the 2 small numbers. So like in number 12, I will add 4 and 7. And it's saying if it's bigger than 10. 11? For number 11, let me add the 2 smaller numbers. I know 7 is one of them, and one of the 10s is the other small number. So I'm going to add 10 plus 7, and it's asking me if it's bigger than 10. 10 plus 7 more than 10? Yes. Alright, then, let me move into something like number 13. Only 2 sides given. 2 sides of the triangle have the following measures. Find the range of possible measures for the third side. Now I'm going to say my value x, the third side, I'm going to say it's in between 3 and 19. And for us to remember, the 3, because I subtracted my numbers, 11 minus 8. That's how I got the 3. The 19, I added my numbers, 8 plus 11. So you subtract them for the small number, and you add them for the big number. Alright, and that takes us until the front side. Any questions on the front side of the review? No. Remember, the test tomorrow looks pretty much like this. Now I'm looking at number 17. We have some rules that work and some rules that do not work. We covered 6 rules. So looking at number 17, right, it says say the 2 triangles are congruent if the arcs state height we know. I noticed that each triangle has 3 sides marked. So 3 sides is 3 S's. Is side, a rule that works?
Yeah.
So then there we go. Now, any questions up until 20?
18.
18? Looking at 18, because the vertical angle theorem, when there's an x form, I can mark this angle with this angle. Right? Because the vertical angle theorem, I can mark those angles. Now let me take a look at one triangle. You guys can see which one I'm looking at. And there's 2 of something. Is it 2 angles or 2 sides? 2 angles? So we have 2 angles marked. Is the side in between the ends? No? So let's put it at the side. I take a quick look at the other triangle. It is marked the same way. Is angle, side a rule that works? Yeah. So then, there you go. Angle, side. 19. I can legally mark the side that they both share. So I'm going to look at this triangle. Is it 2 angles or 2 sides? 2 sides. is the angle between the sides.
Mu.
No? So I'm going to put it there. Is angle side side a rule that works? No. Remember I said no bad words on your paper? It works only if it's 90 degrees. That is not 90 degrees, so not congruent. But then if it was 90 degrees, I wouldn't call it angle side side. I would call it HL. HL for hypotenuse length. If it was 90 degrees. Alright, I'll let you guys do number 20.
Oh, it's easy.
Alright, now let's take a look at the easy stuff. The proof.
Easy.
The proof. Alright, I'm calling it easy because some of the answers are given. Right? We have 3 statements that are given. So we know they're true because they're given. Looking at statement 1, how do we know O is the midpoint of LB? Because it was given. So in your recent, just write given. Statement 2 is T is the midpoint of SR. How do we know it's true? Because it was given. Statement 3 says LB is congruent to SR. It was given. See, so far so easy. It was given. Alright, I'm going to use statements 1, 2, and 3 to come out with statement 4. Just to know, for me to know what's going on over here, LB, O is the point in the middle. Can I say that LO is congruent to OB? Is that true? Because of 2, can I say that ST is congruent to TR? Yeah, that's true. Because of statement 2. Okay. And I have something about LB, something about SR. I know LB is congruent to SR. Can I say all those 4 are equal to each other? Yeah? Okay, so now for number 4, let me take a look at OB. Can I come and say that OB is congruent to, let me take a look, ST? Is OB congruent to ST? Yes? OB, ST? You said they're equal to? How do we know? What was it? Substitution. I don't have room in my space, but I'm going to write it over here. Substitution. Remember, every time you come over and say, this is equal, this is equal, this is equal, then that's equal. Every time you start using the equal, 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 that's substitution. Alright, looking at number 5, that came from nowhere. Right? There's no arrow that goes to 5. But on both sides, it's the exact same thing. SV, SB, reflex. So I don't have room up here. My thing doesn't fit. So I'm going to go reflex for my reason for number 5. I notice my statement of number 6 is blank. What should I write there? OS congruent to BT? Nice. OS is congruent to BT. Right. The proof statement, that's our last thing. Okay, so we know that. Let's see what this actually says. I know OS. Looking at my picture, it is OB plus BX, right? That's OS. BT, for me to understand what BT is BS plus ST, right? Remember how earlier in number 5 we said that BS was congruent to BF? I'm waiting for this thing, it just froze for a minute. Oh, there you go. So we said that these two are equal from number 5. If you remember 6, I said OB is equal to ST. Why can I say OS is congruent to BT?
Because it's not.
It is.
Oh, it is?
your reason, right? Substitution.
What is the substitution?
You see how I came over and said BS is BS, OBST, OS is congruent to BT. Then it's substitution. You're saying how is it substitution? Okay, we know that OS is the same thing as OB plus BS, right? Since OB is ST, and since BS is BS, I can say that is equal to ST plus BS, right? Which is equal to BT. Okay. Alright. Any questions? Yes. Box 4 says OB is congruent to ST. OB congruent to ST. Yes. Oh, why did I pick ST and not CR? To be honest, when I was doing number 4, notice how I thought it for a few seconds. I was looking at number 6. I knew what number 6 was going to ask me, and I knew I did not use TR, so that's why I didn't use TR. Before I answered 4, I took a peek at number 6. That's why I did not use TR. But I took a quick peek. All right. Did you take over it? Yeah. Thanks.